Perfect. Well, thanks, Jim, and I appreciate the ability to both be a sponsor and a speaker. I think if that puts me in a very small group of people, that's wonderful. I'm gonna go share my screen now, and very quickly before anyone gets a headache, I'm gonna go ahead and go here and start the slideshow. If you do have any questions while I'm going through this, please do paste in chat. And I told Jim that I'm very comfortable with questions interrupting me, so don't be shy. Definitely a lot of these concepts would love to make it as conversational as possible. If we think about Edge Delta, we've thought a lot about AI at scale, especially in observability and security. So I'll be going through the history of the company and the history of observability and security, as well as more recently, most of the presentation is going to be focused on, how do you actually get AI to work at scale? AI is very easy at, hey, I'm a human and I want to type into a box and get it to infer something and return back to me. But if you have, let's say, a system that has 100 events or 1,000 events or 10,000 events per second, you have to be very thoughtful about how do you find those high value information within those giant streams of data. And in observability and security, as you know, having a high amount of high throughput, high events per second data streaming through the environment is extremely common. So a little bit of background on myself. I like to put in there the Windows Who Am I command solely because I worked at Microsoft for about 6 years. Before that, I was at Boeing. Before that, I was doing nanotechnology cancer research. I was also at Sumo Logic for about 5 years. I was a solution architect as well as a regional sales manager in the Northwest. So, my career went from cancer research to being a data analytics and security engineer to being a software developer and a dev lead to going to what I call the dark side, which is sales. And then it was crazy about a year ago when I realized that Edge Delta is now the longest job I've ever had since starting the company about 7 years ago. So we're seeing this telemetry shift from consumer to enterprise. If we think about what we had before, we had effectively these data sets that were being created in a much more distributed fashion. We had, iPhones, we had personal machines, we had whatever else. Obviously, in 2025, as these type of systems start shifting into enterprise networks in the cloud, we are seeing that the amount of devices that are connected are starting to massively exceed the amount of people on Earth. And so 30 billion is about the estimate by the end of this year, where we're going to have a lot of these devices connected to enterprise networks. We're also seeing that it's estimated that about 49% of this world's stored data will reside in the cloud. So much like Sabre, deciding to say, hey, let's go turn off some of these data centers and really go partner with Google. I think that's a great strategy, great approach. This is typically what we're seeing across a wide range of organizations that are deciding to make that. And then finally, 94% of enterprises will use AI and machine learning by the end of 25. I think we've all seen this. I think we all understand the AI wave. We understand the value of it. Now, you have to go implement it in the right way, and there's a lot of trade-offs that you're going to be doing, but certainly just kind of putting your head in the sand and not using any AI in the future is probably not the approach that I would agree with. When we think about AI, what are the typical telemetry data sets that are prevalent today in the enterprise, especially within observability and security? It's the typical, what's called like the melt stack, right? So logs, events, metrics, and traces. The first two, logs and events, are a very good fit for LLMs, right? LLM stands for large language model. Typically, logs are written in normal English, providing these crucial context for these debugging and security forensic investigations and analysis. Events you can think of as probably more rare events. They're probably higher value. And log can be an event, but for the most part, events are typically meant to be a lot lower in volume and a lot probably higher in contextual awareness for the user looking at a specific event. Metrics and traces, also great. We do have LLMs that can start reading time series metrics and even looking at metrics, traces spans. But realistically, the best fit for AI and LLMs is logs and events today. I think we all remember the ChatGPT moment in late 22. Realistically, if we go back to it, and I had to search for an actual screenshot of what ChatGPT looked like back then, which was it had these examples, capabilities, and limitations. The models were not that different. It's not like we haven't had these models for years and years, and actually some of these models and concepts of AI have existed for decades. But using the models for inference was now feasible. It was now nicely packaged up in this web application that a lot of users with no context or understanding of how to run AI could now get value out of it. And I think that was the big thing within this, what's called kind of the Chat GPT moment, is it was easily accessible. If I'm going to be using Chat GPT, even in the end of 22, I don't have to think about parameters or training a model or fine tuning it or understanding what type of API, or this is before the time of MCP or agent to agent. All I had to do was go in a browser and go ask a question, or go ask it to write a poem, or tell me a funny joke. And at the time, those were the things that people were doing. Now, if we think about the value for LLMs for terabytes and petabytes of data, we have to understand that large enterprises today, they deal with petabytes and petabytes of data. But even a terabyte would take a human over 1,500 years to read a terabyte of raw log data. So it's, like a decade ago, I was at Sumo Logic, and most of the organizations we were working with had kilobytes and megabytes of data, right? Maybe into the gigabytes if they were a large enterprise. Some of the largest customers had terabytes, but it was very, very, very exceedingly rare. Now, most of the organizations we work with, they have hundreds of terabytes to petabytes to tens of petabytes of data. And, it's just mind-boggling to think about 1 petabyte taking 1.5 million years for a human to read through. It's just so much data. So what are these LLMs good for? Efficient data processing, natural language understanding, and scalability and adaptability. Now, I did put 2 things in there. I put in relatively, and I also put in a question mark for large data sets, because everything is relative. If we think about the challenges with high volume and scale in AI, 1, tokens are very expensive. Well, for most, like most organizations, they can do a little bit of fine tuning, but nobody is going to really go out there and say, hey, I'm going to go compete with OpenAI. I'm going to go compete with Anthropic. I'm going to go compete with Gemini, and I'm going to go create a better model from scratch. No, you're probably going to take one of those models. You're going to do a little bit of tuning on it. And so the training on its own is fairly infeasible for most. Teams are also building and learning. I would say for every one person who is a extremely deep, well-seasoned AI expert, there's probably hundreds of people on that team that are saying, hey, I want to build and I want to learn more about AI. And so that's just the reality that we're in today. And then also privacy, security, scalability. These are extremely important concepts. We are evolving. I think even 1 or 2 years ago, most of the organizations would say there's no way I would ever put our source data into AI. And now you're seeing a lot of these big AI projects are starting to take off. So whether it's Codex or Cursor or Windsurf or Claude Code, a lot of these tools are now becoming SaaS services that have you put in your source code, be able to infer on that, and really be able to get a lot of value out of it. In order to do that the right way, you do need privacy, security, and control over all of your internal data. So LLMs versus observability platforms on large data sets. I always like to use this example. A $6 latte a day, compounding with interest and everything else over 30 years, would cost you about $125,000 at the end of the 30 years. So pretty big number for you personally. Now imagine that latte was 100 times more expensive, right? Imagine that latte was $600. How many would you drink? And that's a really good segue into when you're thinking about the amount of data, when we are growing that data by an order of magnitude every 2 to 3 years, we have to really think about what are the pre-index optimizations and post-index data tiering that we can do if we want to go enable observability and security systems, and if we want to enable AI within those use cases. So pre-index, what does that mean? A very simple example I would use is if you wanted to filter out a specific log message, you should do that up front versus doing that after it's already been indexed in a premium system. So what are those premium systems? Most of those systems are known as like Splunk or Datadog or Elastic or New Relic or Dynatrace. These are the premium systems that people are saying, hey, if I'm going to go take a log, go and ingest it into Datadog, I may or may not index it, but I've already incurred a lot of cost to get that data up to Datadog just to make a decision of whether or not I'm going to go index it. Now, if you're going to not index it or you're just going to drop that data on the floor, and let's say you're using Kubernetes, like in Google, for instance, there's GKE, great environment. A lot of the Kubernetes project was actually started within Google. And why don't I go and actually filter that out directly within Kubernetes instead of actually incurring the cost to get that data up to a premium system? So that's the pre-index optimization. The post-index data tiering is much more around this concept of using object storage, like again in the Google world, GCS, to say Google and GCS is going to be 100 times less expensive than Splunk or than Datadog or than New Relic to be able to store my raw data sets, especially if I don't need real-time access to them. So optimizing for AI in observability and security is extremely important as our data volumes continually exponentially increase. So we are seeing this continued accelerated growth of streaming data volumes. We are seeing these enterprises shift left and try to do more of their processing data in real time up front in the process. And then telemetry pipelines are there to process and curate data. We can apply AI to observability and security at scale, but again, you're going to need that telemetry pipeline foundation to make it all work without having to break the bank. I'm not sure how much of you guys have ever listened to Werner Vogel's talk. Werner Vogel's obviously big in the AWS ecosystem. He has some great talks out there on YouTube. And a couple of keynotes ago, he talked about this concept. I can't recall. I think it was actually in Amsterdam, where Werner's from. But effectively, they were looking at these different types of houses. And they were saying, we can't figure out why some houses use 50% more energy than other houses. Like identical construction, identical insulation, identical windows, identical reasons why, same roofing, but we don't understand why one house uses, 50% more energy than the other house. And it actually came out to most simple reason, which is if your actual monitor that monitors how much energy you're using, if that's on the first floor as you walk in the door and you see it on a consistent basis, you'll be a lot more conscious about how much energy you're using. If that same exact thermostat or meter is down in the basement where it's out of sight, out of mind, you tend to use 50% more energy. So this is a very basic concept, but we see this all the time when it comes to measuring that data from a volume perspective. You have your data sources, your optimization summaries, you have your destinations and tiers. And then you also are seeing it from a visibility standpoint. You need that granular view into this telemetry data. So, applications, third-party services, you have your logs, metrics, traces. That's a diagram on the right of telemetry pipelines where you can have very low-level granular view into every single one of your data streams, how it's changing over time. So the little green and red numbers, and we can send you a link afterwards, but it really shows you, I'm seeing that, for instance, this log stream is 5 times as large as it was last week. Maybe that's for a good reason. Maybe I want to go take a look at that. And then finally, giving you the comprehensive toolbox. In this example, for instance, on the right, you can see, hey, I might have IP addresses or social security numbers or credit card numbers or physical addresses or emails. There's a lot of reasons why there might be some sensitive data within your logs that shouldn't be there in the first place, but it is for whatever reason. You do need a comprehensive toolbox to be able to scrub that data. And it's extremely important as you start to take some of your data sets and actually feed those into these agentic workflows. So if we look at like telemetry pipelines use in the last 5 years, 5 years ago, we started seeing people optimize a lot of those data sets as they were going into Splunk and Datadog. Then probably about 2 years ago, we started to see people really use big object storage solutions like S3, like GCS, Google Cloud Storage, to be able to store their entirety of their logs. So what that does is it opens up a lot of flexibility and optionality where you say, hey, we're now creating a terabyte or 100 terabytes of data a day. Let's go put all of that data into GCS, and let's take subsets of that data, put it into Splunk or Datadog. If at any point we need to rehydrate that data and pull it back in from object storage, we very easily can do that. And that really allows us to really be flexible about what we need to put into Splunk and Datadog for those real-time use cases. Because again, there's a 100x step up in cost from Datadog or Splunk compared to something like GCS. And then finally, in the last year now, we're seeing AI is very front and heavy, top of mind. I want to really think about what type of data sets can I do and put into agentic AI to be able to get these agentic workflows, to be able to give me value out of AI. And again, that's another 100x step up. So I don't think anyone is sitting here saying Splunk and Datadog are extremely inexpensive or very cheap, but AI, OpenAI, ChatGPT, Anthropic, Claude, Gemini, etc., are probably another 100x more expensive per unit cost of data than Splunk and Datadog. Now, Splunk and Datadog do charge per gigabyte, and these AI solutions typically charge per token. But again, you do the conversion, about 100x step up. So if we think telemetry pipelines are very important to be able to get the most out of Splunk and Datadog, they are going to be absolutely critical in a 100x bigger way in order to get value out of AI. So what's the critical need? The very first thing that's a critical need is this concept of real-time curation and inference. Telemetry pipelines manage these exponential volumes of data. These teams can connect these high throughput data streams with these agentic workflows through use of these triggers. And then finally, these AI agents are engineered to actually make your team better. How do we make your team faster? How do we speed up the decision process? How do we allow these agents to make sure they're sharing context across different teams? That's one very critical need for a lot of these AI use cases. There's another critical need, as I mentioned before, data privacy and security. So within these pipelines, you can allow yourself to put in all of your security policies in place to say, hey, if any piece of my data needs to be shared with an AI for context and inference, I want to ensure that that data is always scrubbed of any type of sensitive information. So this could be like scrubbing various different things out of your source code. This could be scrubbing various different things out of your log files. It could be scrubbing various different things out of, let's say, for instance, a PagerDuty ticket or a ServiceNow ticket, or let's say you're using Atlassian or Jira. Every single one of these things, you want to ensure that the right data set with the right context in order to enable AI is given. But, you have to have all your policies in one place. And again, the telemetry pipelines are a really great way to accomplish this. So what's the value for modern observability and security? Again, I talked about getting faster, right? So how do we extract these anomaly insights? How do we automate root cause analysis? And then how do we save on cost by even making this feasible at scale? One of the interesting things is, as we have these design partners for a lot of these agentic workflows, the thing we tend to hear time and time again is the number one thing they actually care about in the short term is noise reduction, right? If I'm having 5,000 or 500 or even 50 alerts per day fire, and every single one of those alerts takes 15, 20, 30 minutes to triage, it makes it really, really expensive to have any type of alerting or monitoring system because I don't have a big team. I only have a 5-person or 6-person team. So if you're going to give me a noisy solution, it's not going to be very valuable. And the worst thing is going to happen in the long run, which is that my people are going to start to ignore the real issues that start to pop up. So how do we use agentic workflows to basically just reduce that noise and take off some of that manual grunt work? That's a lot of what we're seeing today at the low level of maturity. How fast AI is moving is how do we just go enable some of these agentic workflows to go provide very real, tangible value to my teams today. And a lot of that is noise reduction. A lot of that is automating some of the manual root cause analysis. And again, sharing context across the various different teams. If we look at the case studies, you can go to our website and look at all the various case studies and enterprises using AI. But we have Box, we have Employ, we have Sinclair Digital. These are a lot of the organizations that are shifting left using telemetry pipelines enabling the right data sets to go into the right agentic workflows. And that's giving them a big, big improvement in how fast their teams can work and how much shared context there is for the teams to be able to work much better. So that was pretty much it from an AI at scale in observability and security. That was the quick and dirty. Feel free to reach out to me. I'm also here for the next, I believe, about 30 minutes to be able to answer any questions. But excited to kind of field the questions and have a conversation now.
All right. No, that you had the pedal to the metal and hitting all the high points. Yeah, definitely appreciate that. So anybody that has questions, you can enter them in the chat. I'll ask Ozan. And if you don't ask any questions, that means I have to think of all the questions. So please, please, put in some questions.
Well, let me jump in here for Partha, because I think Partha, I don't think it was a question, but let me just kind of touch on that. I think you made a great point. You said using LLMs with unstructured log data makes the log data interpretable and can be converted to structured format for analysis. That's a great point. So there's a lot of discussion today. I was actually just meeting with a customer today, and they said, it's really funny. What we're finding internally is that the way you would even, like a technology that's as old as time, databases, the way that you would design a database for a human is actually potentially very different than the way you would design a database optimized for AI. And we're seeing this in real time, is that people are starting to think through, what do my systems look like in the future if I'm going to start building this for AI instead of building this for humans? How do I re-architect my systems? How do they look different? We had to do a lot of that with telemetry pipelines, right? Our original product from 2-3 years ago required you to go in there and write all sorts of rules to transform data sets. And we thought about it and we said, okay, wait a second. If in the future 60 or 70 or 80% of code is no longer written by humans, then who are we to tell you to go into our product and do all the manual things on the logs that you never even created in the first place, right? So I think it's a great point, Partha. We basically are really kind of thinking through, what does the future look like? How do you want to structure this data to make it most prevalent and available and useful to these agentic workflows?
And then he has a follow-up statement on knowledge graphs, knowledge graphs, trying to embed the things that your humans know into a knowledge graph so that non-human agents can leverage that knowledge, feed it into the large language models, hopefully making the agents do a lot more of the work, like high levels of work, not just low-level grunt work, but maybe some sophisticated things kind of down the line. Are you seeing, I don't know, maybe you've done things like that at Edge Delta, like behind the scenes, just using knowledge graphs to help you guys be more productive?
Totally. Like if you think about it, right? Let's take a metric, for example, right? Whether it's latency or error rates or millisecond response times for a specific service, timeouts. There's 1,000,001 different metrics you might use to determine the health of your system. Metrics is very unique in that when a metric is 15 minutes or 30 minutes or an hour old, it is exponentially less valuable. Logs aren't necessarily that way. Like you can still use logs to debug something. You can still use logs to go investigate something, but metrics are very unique in that, like, they're very, very valuable up front. And so the funny thing is, a lot of these observability and security use cases, especially for observability, metrics are very important, but it's also this real-time current view into the system. So we also have to think a lot about, okay, we did this investigation. We looked at this metric. Okay, that told us what was going on, right? Now we're going to look into the logs to understand the why. Like, why are we getting this spike in error rates, or why are we getting this longer latency in the service to return? Why are we getting these timeouts? And so we start looking into the logs, right? Now, what you're doing is you're basically going through this a structured, logical set of investment or I would say analysis using your own time, right? This is your time that you're using. And then we think a lot about, okay, if you were going to go turn that into a playbook or take that and vectorize it, so that AI could actually be like almost within a knowledge graph vectorized. Okay, now AI could use that, and maybe in the future it does things 5 times faster, or maybe let's say, for instance, it just does things 5 times more efficiently and uses 5 times less tokens, and therefore it's 5 times less expensive within that engine workflow. So I think that is something that we think through a lot, is like, what do you want to vectorize? How do you go take the current workflows and go, basically turn those into knowledge and be able to have both agents and humans use those in the future. And then Mohammed, it looks like you had a question on cost. For the sensitive data piece, how does Edge Delta invoice this to customers? So scrubbing or masking at the source level before indexing. Is it accounted by log volume? Yeah, so great question. What we do is we actually say, hey, in all these other systems, let's say you want to put your data in GCS, and then you also wanted to use Datadog, and then you also wanted to use, I can't remember what Google renamed Stackdriver. I think it was called like
Google Cloud Operations Suite.
There you go. Google
Very
Cloud
generic.
One of my first jobs at Microsoft was actually in BPOS, Business Productivity Online Suite. So it's great. It's coming back after like almost 25 years. But no, I think one of the unique things about Edge Delta is because we're a pipeline, you pay once only for the data. So we have organizations that say, hey, I want to go send that to 10 different places. Do I have to pay for it 10 different times? Absolutely not. You can go take your data, you can go transform it, you can do whatever you want with it. For us, if you think about like our cost and our pipeline cost compared to Splunk, think about like orders of magnitude. It's like 20, 25 times less expensive. So it is a very small cost to be able to use our pipelines at scale. And most of our customers will use them within these more next generation technologies like GKE, for instance, right? Within Kubernetes, to be able to have these pipelines that are distributed, that can allow you to do any different thing that you might want with your data, from sampling and masking and pre-processing, aggregating, hashing, or doing anything else with your data. It's all completely up to you.
All right. Just looking at the chat, I'm not seeing anything in there right now, but definitely ask as many questions as you guys want. So say, Ozan, say I'm a new, I don't know, relatively new person in technology, or haven't been in that, I've been in the application developer space where I know I write logs, it seems, and I know my logs, but I'm not quite sure what I want to send to the back end. And we've seen this in our move from to Google Cloud to cloud. They just call it Google Cloud Logging. So we've had people have to go in and optimize how many, what to actually send out, because it costs a lot of money to store it there. If we combine like 14 lines in a row and just shove it in as like one big thing, it costs us less money. If we use some filters and leave some things, on the floor that we don't care about to analyze later, that saves us some money. Is there any, and maybe Edge Delta has this published already and I don't know about, any like best practices type things that newbies getting into that log, that log shipping, log pipeline, telemetry pipeline work that they may not even think of, because it's hard to imagine imagine things from the beginning, where if you've been working in that space 6, 7, 8 years, that it's just like, yeah, these are well-known things.
Yeah, no, I think it's a great question. So funny enough, in our product, we actually have AI recommendations. So what ends up happening is, and it's funny because, you mentioned GCL, even like between BigQuery and GCL, right? Like they have different pricing models, different kind of structure for what you're going to be using. Like if you think about a data warehouse, you think about almost like batched queries, non-real-time use cases. Then you think about logging, and you think about, okay, it definitely needs to be more real-time. And there's definitely trade-offs there from batched versus streaming. But within our product itself, if you were to set it up, for instance, to say, hey, we want to go from GKE, use Edge Delta pipelines to send that data into Google for GCL use cases. we actually will continually sample that data within pipeline and give you recommendations using AI to say, hey, we've noticed, for instance, hey, maybe you have PII data. Maybe you need it. Maybe you need these IP addresses downstream for whatever reason. But hey, we're just letting you know that we found it. And if you want to mask it, click this button, and we automatically apply that rule where the user doesn't have to think through, oh my gosh, I got to think about this regular expression and go and find it online and copy and paste it. It just does it all for you. So it is very recommendation based. Also, we do like a clustering analysis. I think, Jim, you're probably alluding to this compression that we do for the data. We do kind of compress all your data into effectively like a table of contents that show you all the different patterns within your data. And you can look, and funny enough, Jim, most of the time that customers will deploy our product, they look at the compression and they say, so you're telling me that one log line right there, that's 24% of our entire data set? It's like, yeah. It's like, that's not even valuable. It's like, you can decide whether or not it's valuable.
Like only the timestamp is changing and...
Yeah, exactly. And it's just like some random log message that just doesn't provide a ton of value. And they can literally in our product, they can just click it and say, okay, I want to go remove this from downstream destination. So it's very easy. But going back to that Werner Vogel's analogy of like the meter being in the basement versus the meter being in front of the front door, this can have a drastic impact on how efficient your systems are. And what pipelines just allow you to do is, hey, let's just give you the full visibility, give you the comprehensive toolbox, and you can use that in whatever way to optimize whatever data sets. And it looks like John had a question here. Do you see Edge Delta MCP coming anytime where customers' agents? John, I don't know if you're leading the witness here, but we did release our Edge Delta MCP about 6 months ago. We do have another product coming out that kind of takes it to almost Edge Delta AI 2.0. But even today, you can today already use Edge Delta MCP that we released. And we have a blog post about it. I'll happily share that with you, John. And then Mohammed said, example, Lambda start execution log message. Yeah, exactly. I mean, there are a lot of, in the case of Lambda, for instance, you're typically putting in like a Lambda extension to go post a message outside of Lambda. And a lot of times, yes, it could be something very valuable. Like you say, hey, every single time I go post this message, I want to go include this metric and this specific metadata and whatever else. But exactly to your point, Mohammed, sometimes it's just like, hey, this is just like a basic message that doesn't really say much. And holy crap, it's 20% of our data. This is really costing us 20% of the cost. A lot of times, sometimes magically it is. So it's a great example, Mohammed.
So I'm going to get in more, not more technical, but just kind of deployment type thing in case people haven't had a chance to look at Edge Delta before. If they wanted to roll it out somewhere on VMs, is it just like an agent? Other cloud services like GKE, how does that work? And is there certain, I don't know if there's certain parts of cloud, maybe there's other services from cloud you're able to feed things in through API, and not just from cloud, I guess, maybe how do you connect up and pull in data? I don't know how to end this question, Ozan.
Yeah, no. I think where you're going.
How would they get started? What does it look like?
So at Edge Delta, we have every single way you could imagine to deploy Edge Delta. So you could have cloud fleets, you could have gateway agents, you could have daemon sets, you could have sidecars. In the case of Windows, for instance, you can just deploy an agent directly on a Windows VM or a server. So every single way for network data, UDP, TCP, you're just going to deploy and act as a syslog listener on any specific server as well. So there are lots and lots and lots of ways that we support. Now, our most common use case is probably Kubernetes. Our most common way to deploy is probably using a Helm chart within GKE. And so that's a very easy way to get up and running. When you go to edgedelta.com and you go create an account, the first thing you actually do is it just basically gives you those commands to run, and it gives you the Helm chart and everything else. And you can just go do it, and it takes you literally maybe 1 or 2 minutes to go deploy and get it up and running. So I highly encourage anyone, if you go to edgedelta.com, you can just click on the button in the top right of the website and just go deploy, and within minutes within Kubernetes. You can even use Minikube directly on your dev box and go deploy. but it's a very, very, very easy way to get up and running. And one of the cool things we do also is like out of the box, we give you a lot of this out of the box. So when I talk about patterns or cluster analysis or the distributed machine learning that you can use, all this comes out of the box. eBPF, service maps, tracing, again, all of it comes out of the box. The other thing that's really cool is we automatically OTelize or OCFSFIs all the data on the way through. So, you might have a very valid reason for using OTel format in a downstream destination, or you might have a very valid reason why you don't want to OTelize something on the way down. So all of that's supported, all of it comes out of the box. And like I said, Kubernetes is probably our most popular use case.
And it sounds super easy to set up. And from the previous question where, maybe I don't know how to save myself money on the back end, I could just set it up, let it run for a week, and it'll start giving me suggestions on what I should, log lines I should live. Maybe it doesn't even take a week to give suggestions.
Yeah. So, I mean, you can set it up, and within 5 to 10 minutes, you get that analysis of all of your logs. So that's the first thing you get. Then you start getting the recommendations. Then after a week, you start getting a lot of these trending analysis. So a lot of people, for instance, come back to us and they said, I don't really care about Friday versus Sunday because my systems are very different on those 2 days. But I do care about Friday versus last Friday, right? Or Thursday versus last Thursday. And so in that case, I really do want you to put an emphasis on week over week analytics. And we've done a lot of that, right? So to your point, within the first few minutes, you automatically get an analysis of your logs. Within let's say a couple of hours to a couple of days, you're going to start getting those recommendations. And then from there, once you surpass a week, you start getting that week over week analytics. And that's really also where it starts to become very exciting, is you start being able to optimize your data sets and be like, oh, wow, like we are down 20% week over week within this data stream, which makes this also conveniently 20% less expensive for us. Looks like Farhan has a question.
Farhan has a question there.
Are there any guidelines or best practices for AI architectural roadmap when it comes to observability, latency, tokenization, vectors, LLMs, hosting, etc.? I think there's one really, really, really large consensus right now within AI that everyone agrees on, which is you need these human experts involved in a big way. So I don't know how many of you have used like Replit or Vercel or Lovable or Cursor or Codex or Windsurf or any of these solutions. Claude Code is probably the hottest, most recent one right now. But effectively, the reason why these coding tools are so good, it's no secret, is because the people that have built these initial AI systems are developers. So it's like the first thing that's going to get really good is a thing that developers are really good at.
Yeah.
Like the reason why we don't have an extremely good marketing AI or an extremely good sales AI or any other competency AI yet is because salespeople aren't building AI, right? So it'll happen in time, absolutely. And I think for the guidelines, best practices, I think I wouldn't overthink the, whether you're using RAG or vector databases, or you're doing this type of inference, or you're fine tuning, or you're trying to go train your own model if you're crazy enough to do that. I wouldn't, I think, over rotate on that stuff. I think I would say, what is a very tactical, sensible thing I'm trying to accomplish with AI, and how do I go iterate? So if I'm going to go use a platform that says, hey, it allows me to take a model off the shelf. It allows me to go take these data sets. It allows me to go do these workflows, and I can just iterate and iterate and iterate. I will say, like, almost every single use case is going to be pretty janky and broken at the beginning. And then in the long term, the hope and the dream is that you get to iterate on it with your human experts to get it to a good state for your use case. So I think, the best practice would just be iterate as much as you can.
No, that's great. I do have a question that I ask everybody. It's not a technical question. I ask all our presenters. It's a career question, a growth question. But most of our presenters are seasoned technologists and have been through a lot of seasons of life and seasons of technology. If you could jump back in time to talk to a younger Ozan or talk to a young person now. Sometimes we get some college kids or people straight out of college that join our sessions. Any kind of career advice that you like to give people, whether they're going to go into technology or not? It doesn't necessarily matter. If it's technology focused, that's fine as well. But any advice that you'd give to some young people or even old people looking for a boost?
Look, I think I'm a firm believer that we're all really great at something. Like we all have very high potential to be incredibly high performers at something. And especially like if you're thinking about more of an entrepreneurial path, and let's say you were saying, hey, I want to go raise some money from some venture capitalists, and I'm going to go build my startup, and I'm going to go raise more money and go IPO, and then go be the next NVIDIA. It's really important if you're going to go on that journey, for instance, to really look at your career and look at your experience and say, here is what I'm the best in the world at. And again, it can be something hyper specific, right? It could be like, hey, because of my background, because of my upbringing, because of my culture, because of, whatever reason why you might have some unique set of circumstances and experiences and knowledge and these career projects you've worked on and everything put together, that's your story, right? That is you. And that gives you a unique combination to be the best in the world at something. And so especially if you're looking for from a career standpoint to look at, hey, there's a reason, for instance, that I might be the best developer to go work with AI and observability and meshing those two things together. You have to be really, I think, thoughtful and transparent with yourself and self-aware to understand that what you're the best at and then go and do that. I don't know that I necessarily believe like, oh, do the thing that you love and you'll never work a day in your life. I don't know about that, but I do think that people want to feel like they're really good at what they do. And I do believe that every single person can be really good at something. So that would be my advice is go find the thing that you feel like you're really good at. I'll give an example of myself. I started my career as a software developer at Microsoft. And I think, for Microsoft standards, I was, maybe average developer. Like I was good. I was, I got my stuff done. I got it done on time. I impressed some people, but I was never great. Like I was never an all-star developer. Like my co-founder and CTO, Fatih, he was that guy. I mean, he was incredible. And whenever I had some very, very complex thing I was trying to build, I would go walk over to his office, even though he wasn't even on my team. I would go walk over to his office because he was a friend of mine. And I would say, hey, I need you to help me with this thing, right? When I started getting more into customer-facing solution architecture and being able to marry the technical concepts with also understanding the business needs of the clients, I really started to elevate myself. And I was able to actually say, wow, like I don't think I ever could have been a superstar software developer, but I actually felt much more like a superstar, almost technical liaison and trusted advisor to a lot of these organizations. The other thing I got was at Microsoft, for instance, I remember back in like 2010, I worked on getting GPUs into data centers in Azure. And this was 15 years ago. I mean, this was literally, I think it was almost the same year that Bitcoin was invented. I think Bitcoin was invented in 2009. So nobody had any need for GPUs in data centers. I mean, there was no reason. It was just like Azure saying, hey, AWS is ahead of us. And how do we go compete with AWS? Oh, let's go put GPUs in data centers. And I think we had one customer. It was like an internal Xbox team that needed to render some video for some galactic warfare starship game, right? And when I moved on to the next project, I realized that I knew more about GPUs and data centers at scale than probably anyone except for 2 or 3 humans on Earth. And yet there was a 99% chance that knowledge just wasn't going to translate to my next job, right? Like it just, no matter what, my next job has nothing to do with GPUs and has nothing to do with making them work at scale in data centers. And so when I joined Sumo Logic shortly. I went to a few other roles at Microsoft, but I joined Sumo Logic afterwards. And when I was a solution architect, I never, of course, went that deep with any customer, but I started working with hundreds and hundreds and hundreds of different companies of all various shapes and sizes, and some giant Fortune 100 enterprises, some small startups, and you start to see context. You start to see like, oh, this team's doing this thing really well. Oh, this team is kind of, for whatever reason, it could be a valid business reason why there's something broken, it feels like, in their process. Sometimes you feel like you're a little bit of a therapist. Sometimes it feels like you're a little bit of a scientist. Sometimes it feels like something in between. But that was, I think, a breath of fresh air for me to say, hey, at Microsoft for 6 years, I went very, very deep in these projects. And then all of a sudden I went more customer facing, and you just have to find that thing that you're really good at.
Yeah, it sounds like, definitely everybody has their own unique experience, maybe different skills that they've stacked along the way to make a unique combination. And then just trying to find that awareness to move into that direction where you can, I guess, be your own superstar or something like that.
Yeah, exactly.
No, that's great. Looks like Partha was adding on to Farhan's or your response to Farhan.
Yeah, I think Partha, I think you mentioned framework to iterate. Right now, I don't think anyone thinks that anyone, whether it's myself or even Anthropic or OpenAI or Microsoft or Amazon or Google or Gemini, I don't think anyone feels like this thing is figured out. We're in the very early phases. I think everyone sees the tremendous amount of potential. I joke, like, people talk a lot about, like, are we in an AI bubble? I think two things can be true. I think we can say we are in a massive AI bubble. And also, once that bubble pops, the thing that's left over, the real thing underneath the bubble, is also going to be the biggest thing in our lifetimes. So it's like, even though there's this big bubble, there's also the biggest thing in a very substantial, meaningful way underneath that bubble that is, I think it's exciting. I think it's going to allow us to rethink the way that we do things. I think it's going to allow us to build a lot of systems. I think, frankly, it's going to allow people to create startups and innovate and create opportunities for themselves and others much faster than previously. People talk about, oh, the 10-person startup now is just as powerful as a 100-person startup was, 5 or 10 years ago. So I think that's an exciting time where, I had some big time panelists at one of our AI events the other day, and they said, look, it's probably, definitely bigger than, let's say, the iPhone, definitely bigger than the cloud, probably bigger than the concept of the internet, and almost as big as the concept of software as a whole, right? And that's pretty crazy when you think about it. Like, the only thing bigger than it is just the concept of software in general. But otherwise, it is going to be very meaningful, and time will tell. But I think there's definitely a tremendous amount of potential, and I think that's the opportunity. So, Partha, like you mentioned, framework to iterate. Like, every single person, I go talk to the head of product at OpenAI, and they say the same thing. Like, I give them feedback on the product, and they say, "Thank you so much. Yeah, we think it has so much room to improve." Right? Like, that's the mindset we have to have with AI in these systems, because everything is so immature at this point.
Well, looking at the clock, looks like we're closing in on time. Really appreciate the questions in the chat. Ozan, really glad you could carve out some time out of your busy founder and startup running day to join us. Really appreciate that. The AI is not going anywhere. The data that will need to be moving around is not going to get smaller. It's only going to get much larger. So really appreciate you joining us. I'll grab the slides from you when you get a second. I'll share those with the recording. If anybody missed the beginning, just come back to the event page where you logged in. I usually have it up by Monday. So if you check on Monday, you'll see the link there. There'll be the YouTube video, Ozan, that you'll be able to share wherever you'd like to share it as well. And yeah, really appreciate it. Thank you very much for being a speaker, and once again for being a sponsor of a GDG Social Club. The only second person to have done both.
Okay, well, that's great. I'll gladly be number 2 in certain situations. Well, thank you so much, Jim, for having me. And again, feel free to add me on LinkedIn or message me on LinkedIn as well. Any type of questions or anything else. Really appreciate the time. Appreciate the questions. And like I said, I'm excited to see what us and you all can build. And yeah, send me some cool AI projects too if you're building it on the side. So always happy to take a look.
All right. And so what happens next? Anybody that wants to stick around, we'll have Mike Shirk from our GDG group and Eugen from our GDG group. They'll lead a mini online networking session if you'd like to get to meet some people. I can't join this. I can't join this month, but they'll be running it. I'll put up a 5-minute timer. After that 5 minutes is done, I'll have made everybody a presenter, so you can turn on your cameras and mics, and yeah, just have a little get to know each other session. So, Ozan, once again, thank you. It was great, and I can't help thinking the whole time that you're doing a green screen movie. You're going to replace that background with some action at the end of this, but yeah. Really appreciate it.
Yeah, no worries. I think I'll think about that for next time. It might be a way to spice up the conversation. Thanks, Jim.
Yeah, take care. So I'm going to stop the recording here.